This here is a prism that I have set up outside. You can see outside, there's my yard. I can point this to the sun, it won't hurt your eyes. I won't look straight at the sun though, but there's the sun. And the sunlight is shining through this prism. And prisms, if you've never seen it before, create a beautiful pattern of light called a spectrum. Basically, the white light from the sun can be broken up into all its parts, all its colors. There's a lot of colors associated with sunlight, and a prism allows us to see them. I gotta see if I can get the angle right here so you can see it. I think you might be able to see that. I can't see if you see that, but that is the prism. Light coming out of the prism, I should say. And you can see on the lower part of it is red, and the upper part of it is, as you get higher, it goes yellow, green, kind of a blue, and then a violet maybe a little bit towards the end. And that is the solar spectrum. And so all the light, including light you can't see, is being pulled apart by the prism because it bends at slightly different angles because of the process of refraction that occurs when the light enters the prism and leaves it. I'll also try doing this on some lights in my house so you can see that there's a difference. And that's really all I'll be able to have you do in this lab, is just look at the difference between sunlight and light from my house, which is going to be very difficult to see as striking a spectrum as this. All right. Okay, this is a video of a spectrum that I'm collecting from an incandescent light. That's a light that has the little filament that burns, and the temperature of that filament affects the wavelengths of the light that's put out. You see this one probably has a little more red in it and a little less yellow and green and blue than the sunlight did. It's a little hard to tell exactly, but you can get some idea that there's a slightly different spectrum here from this incandescent bulb. Okay, this is the spectrum from an LED light. This one, it's a little harder to separate, but you can see that you can see some red and blue, and probably there's a bit more yellow in the middle than in the case of the other one. So different lights have different spectra depending upon how they work and the mechanisms used to produce light. LED is a different mechanism than an incandescent light. That's the LED bulb I'm using, by the way. Hi, this part of the lab involves looking at color. And the way I'm going to do that is to show you that the colors on the screen that you think are white or yellow or whatever you think they may be. This one's white, for instance, this one's yellow, red, green, blue, purple, black, gray, orange, are actually comprised of a lot of other colors. And to show you that, what I'm going to do is photograph them close up, but using this lens here to really get a close up, and you'll actually see that what you think is white all of a sudden looks like there's a lot of squares in there. And you'll see that, for instance, here's a photo of it right here. Watch this. That's a photo of a white screen, believe it or not. That's what a white screen looks like if you magnify it. And in this subsequent video, you're going to actually see even higher magnified versions of this, and you're actually going to see some more, that there's colors in there. There's little pixels. And I'll step you through them for each of the colors, and you'll see how they're comprised of different pixels of red, green, or blue color that have different intensities, the combined color of which is the color that appears to be what you see. It's really interesting, and I'm going to step you through that. It'll help you fill out one of the tables in the lab. It'll kind of give you an idea of what can go in there. All right. Okay, I'm going to step you through these slides. This one is white, and I should have mentioned in the previous video, I normally use a little microscope to look at these pixels on your iPhone, actually. But I didn't have that microscope with me. That was one of the pieces of equipment I neglected to pick up from the physics lab. So I resorted to figuring out ways to do it with cameras and lenses as best I could. But watch this. I'm going to magnify it. As I magnify it more and more, you start to see evidence of red, green, and blue pixels here. It's a little hard to pick them out as well as I'd like because of the resolution. But when I magnify it, you can definitely see that there's squares that are comprised of actually little pixels, which are what the computer screen produces to make the colors that we see. So this is white. It has all three of them. Let's look at a yellow one. This one here is yellow. And this is yellow, of course, that, remember, I looked at it through a magnifying glass and photographed it. So that's what the yellow screen looks like when you magnify it that much. Now, if I magnify it even more, you might see evidence in here of red and green pixels, and that's what comprise yellow. The green look a little like yellow on this screen, and again, this would have been better if I had the microscope. But you can see that yellow isn't truly just yellow, even though it might look like that from when you see all the pixels really close together on the screen. Your eye mixes them all together and creates this yellow color that people, physiologists for hundreds of years, have been trying to figure out how we see color. All right, going to red. Now red is the actual pixel color of the screen, and that's a pretty pure color. Although as you get different shades of red, you can have other amounts of blue and green mixed in there. But this looks pretty close to pure red. I think you may have some pixels that are darker red than others, but you get the idea here that it's pretty much red pixels that comprise red from what we can see here. Okay, that's red. Let's look at green. As you might expect, green is going to be pretty pure also, because the computer is capable of producing green just in different intensities. And there you go, you see the green pixels. Go to blue again. We would expect to see that this is mostly just blue pixels, really close together, and maybe some different shades of them to get the color that we have. But that's blue pixels. Purple. Let's see what we can make out of this one. As I magnify it, see how big I can get this. There we go. Looks like there's some red and blue in there. I'm not sure I see green, but purple is typically a mixture of red and blue, and different shades of purple might have different amounts of red and blue and perhaps even some green. But that's the purple pixelated screen. And after purple, I think we went to black. And black seems to have various different colors in there. It's a little hard to see with the resolution I have what the black consists of completely. But you can see it's more than just black as I home in there again. It's hard to see again all the pixels, but I even see elements of red in there. So black actually consists of more than just black. I mean, if you turn them all off, you get black, but some of them are on. It actually phosphoresces slightly, even when it's black. So this one's a little hard to tell when you write that on your chart on the lab handout. I'll go to gray. Gray looks a little bit like white, doesn't it? Except I don't see any red in it. I see more the greens and blues. Don't see so much red in here. But this gives you an idea of how we actually create gray color on a computer screen. And finally, orange. Here's an orange. Definitely some red in there. Let's see if we can see anything else. I think there may be some elements of green in here too. But hopefully you get the idea that these colors are comprised of these 3 pixels mixed in different amounts.